Assalamu alaikum. This is Team NSB's demonstration of the snake and ladder game project. Here we have our port module, which is our dice module. This is our memory module. This is our winning module. These two are used to light up the two LEDs of two players. This is to light up the two LEDs of ladder. This is to light up the two LEDs of snake. Here, this part is our main snake and ladder logic. Here, in the board module, we have used red LED for player 1, blue LED for player 2, green LED for ladder, and yellow LED for snake. We use such 15 blocks to show 15 positions here. Here inside these two things have a simple decoder here whose input is coming from the memory and output is going to the board module. It's same for player 1 and player 2 here. Now, this is our ladder bottom and this is our ladder length. This ladder bottom is driven into a decoder here, and the addition of these two, the ladder bottom and ladder length, by this adder, and its output is driven into again a new decoder here. The output of both of the decoder is driven into XNOR gates here. As our board module is of active low, we use XNOR to light up two LEDs. Similarly, for snake, this is a snake head and snake lamp. This snake head is driven into a decoder here. And after the subtraction of snake length from snake head, using this subtractor here, this subtractor is made by an adder with XOR gates. The output of this subtractor is again driven into another decoder here. The output of both of the decoders are similarly driven into XNOR gates here to light two LEDs of the board. The output is going into the board module here. Now for the main logic of our circuit, we will first go to dice module here. Here, inside our dice module, we have a 555 timer. This is used to generate clock pulse, which is driven into these two JK flip-flops. This part is our counter, which will start counting if you give a logic input of 1 here. This is our BCD to 7-segment display to show the values of our dice, and this is a mask is used to give the values of the dice to two players depending on this bit. Now, after we get a dice value from this dice module, we'll go to this player, let's say for player 1, adder here. This input of this player position will come from the memory here. After adding the player position and the dice, we'll get a new player position here, which will be our output. Here we've used the marks here by keeping in mind about the invalid cases. Let's say we are in position 14. We've got a dice value of 3, so it will stay on 14 according to our project. So this is used to implement that. This goes same for player 2 here. Now after we get the new position of player after addition of the dice, we'll go to ladder bottom comparator and snake head comparator. Here we just use two simple comparators here. The new positions are compared with the ladder bottom, and here with the snake head. This is for player 1, this is for player 2. If ladder bottom matches, we get a ladder value 1 value here. Snake head matches, we get 1 value here. Now after comparison, we'll go to ladder adder or snake subtractor here. Depending on the values of these two pins, this circuit will act as a adder or a subtractor. Here, if you get a value of ladder 1, these marks will pass the ladder position, ladder length position here, which will be added with the player position here, and we will get the output. If we get a snake value of 1 here, then this snake length will pass through these marks, and due to these XOR gates and due to the positive value of 1 here, we'll get the subtractive value here. Now, if the ladder length exceeds the board, or if the snake length exceeds the board, the LEDs the player position should stay in the position where it was. So to implement that, we've used 2 marks here, one for the ladder logic and for the snake logic here. And these two are given to for OR gates, which are the outputs here. These outputs are going into this memory module here. Here for a memory module, this is our truth table of our memory. We have a control pin here and an input value of I. If the control pin is 0, no matter what input we give, it will hold the previous values here like this. If it is 0, it will be 0. If it's 1, it will be 1. Now, if the control pin value is 1, whatever you get the input, the output will be the same here in the next state. So we'll get the circuit like this using the flip-flop. Now this is for 1 bit. As our player position is of 4 bit, we've used similar 4 blocks of the same circuit like this: 1, 2, 3, 4. Yeah. And these 4 are for pair 2 here. Now, whether this will be activated or hold the value or update the value, or this will hold the value, update the value, will depend on the control pin, which is selected from the player switch here. This is our player switch. Now, if the values of any of one of them reaches 15 here, it will go here. Here inside we just have 2 simple comparators, one for player 1 for player 2. As our last goal is to reach 15, we've compared the values of the player 1 and player 2 with 15 here, as 15 is 4 bit of 1, 1, 1, 1, 1. We've used power of 1 with all of this. If we get 15 on player 1, this will come to LED 1, this will come here, and this light will blink and we will get a buzzer sound. If player 2 reaches 15 first, we'll get blinking LED here and the buzzer will go on. Now, as our D flip-flops are of reset is of active low, we've used a pull-up register here. If you push this button, this will send a logic value of 0, which will reset our whole board. Now, to reset this dice model, we've said that we need a logic value of 1 for counting here. So for that, we've used this switch here. Here you will get logic 1. If it's down, you will get logic 0. Here we were asked to use buttons, but this is one of our flaw here. We couldn't use the button. Instead we've used the switch.
We have an entire walkthrough of the game. At the beginning, we can see that the player 1 and the player 2 are at a 0-0 position. As you can see, their corresponding LEDs are lit here. I would also like to mention that the ladder bottom is at position 3 and the ladder length is set to 5. So the ladder LED in the position 8 is lit here. The snake head is at position 12 and the snake length is 10. So the snake LED on position 2 is lit here. Here we have a 0. This means that the player 1 is active. If we press this player switch here, it gives a 1 and the player 2 becomes active. This is our dice switch. Pressing this switch will start generating a random number here, and releasing the switch will give us the number output. So let's press the switch for player 1. We get an output of 3, and on position 3 there was a ladder, so the player 1 has been promoted to position 8. Now we switch to player 2 and we press the dice switch again. Player 2 also gets a position of 3, so the player 2 also goes to the position 8. We can see that the player 2 was on position 9 and got a 3, so it went to a snake head and it has been demoted to position 2. Player 2 got a 1 and got promoted to position 8 through the ladder. Player 1 was on position 14 but it got a 3. So this is an invalid case, so the player 1's position stays on 14. Now player 1 got a 1 and has got to the position 15, which means the player 1 has won the game. We can now zoom out and go to our winner module, and we can see that the player 1 has won. The corresponding LED is winning, corresponding LED is lit. So this concludes our video. Thank you for watching.